finding solutions in an interval for trigonometric equations with an angle multiplied by a constant. Once again, our instructions are find all solutions with x in the interval from 0 to 2 pi for the equation. And in this case, let's take a look at the equation tangent of 3x over 2 is equal to 1. So this time we're dealing with a change inside of the argument of the trigonometric function. And that makes a very interesting challenge in determining what actually are going to be solutions. I'm going to start with a substitution. I'm going to start with letting u equal 3x over 2. Now, if x is in this interval, that means that 0 is less than or equal to x is strictly less than 2 pi. I don't want x, I want 3x over 2. So multiply this inequality by 3, divide by 2, and we get 0 is less than or equal to 3x over 2 is less than 3 pi. So we want u in the interval from 0 to 3 pi, this time not the interval from 0 to 2 pi, which means that the solutions which count are going to look slightly different. Taking a look at the equation tangent of u is equal to 1, first thing I notice is that this is positive. Right? I know that all students take calculus, so tangent is positive in the first quadrant and in the third quadrant, not in the second quadrant and not in the fourth quadrant. Sine and cosine are fairly easy to remember as far as their special angles, because it's simply increasing and the same thing decreasing. So sine of 0 is 0, sine of pi over 6 is 1 over 2, sine of pi over 4 is the square root of 2 over 2, then we have the square root of 3 over 2, and then we'd have the square root of 4 over 2, but the square root of 4 is 2, and 2 divided by 2 is 1. Cosine takes the same values and just repeats them backwards. And tangent is the ratio of these things. 0 divided by 1 is 0. 1/2 divided by root 3 over 2 is 1 over root 3, which we usually rationalize to root 3 over 3. Root 2 over 2 divided by root 2 over 2 is 1, and then we end up with root 3, and tangent of pi over 2 is undefined. But what we're looking for is 1, and 1 corresponds to pi over 4. So we have a reference angle of pi over 4. We want u to be in the interval from 0 to 3 pi. And we want our solution to be in the first quadrant or in the third quadrant. So let me go ahead and draw out those reference angles. Here we are in the first quadrant. Here we are in the third quadrant. And normally we only go from 0 to 2 pi, but if we wanted to keep going, we could. Pi over 2 is coterminal with 5 pi over 2, and pi over here is coterminal with 3 pi. So we can take 1.5 loops and still get something that's within our region. All right. So the first one, in the first quadrant, we just get that value itself. So that'll be x equals alpha, or x equals pi over 4. Then we'll take the loop that comes to there. And again, that's pi plus a little bit extra. So we have that x is pi plus alpha, which is pi plus pi over 4, or 5 pi over 4. And then we have one more option, because we can come all the way around like that. All right. For that one, that's not a standard reference angle, but we can figure it out the same way. We come all the way to here, that's 2 pi, and then we go a little bit further. So it's going to be 2 pi plus alpha, which all told is 9 pi over 4. So pi over 4, 5 pi over 4, and 9 pi over 4 are the three solutions to this equation for x in the interval that we care about. I'm sorry, I'm getting ahead of myself. These are not my values of x. These are my values of u, because I have to go here one step further. These are the values of u, and I can use those to find the values of x. So I have that u is pi over 4, u is 5 pi over 4, and u is 9 pi over 4. And I know that x, u is 3/2 x. So I just substitute in 3x over 2 is pi over 4, 3x over 2 is 5 pi over 4, and 3x over 2 is 9 pi over 4. Now I solve each of these, multiply by 2, divide by 3, to get that x is pi over 6, x is 5 pi over 6, and x is 3 pi over 2. There's our three solutions for x in between 0 and 2 pi, which is what we said we wanted in the first place.